Okay, for this video we are going into our family functions book and we are going to do our sine function, and then we're going to do cosine and tangent, and then we're going to go back and pick up on some of the other pages that we skipped. For this video you will need to have your unit circle out because this is what we're going to refer to. So our parent function y equals sine of x. Really, I probably should have said f of theta equals sine of theta, but it's okay. We'll leave it as y equals sine of x. X is going to be the angle, so x is going to be your theta. So we're going to go in radians, 0, the pi over 6, pi over 4, pi over 3, pi over 2, and going all the way around. And then the y coordinate is going to be the y coordinate of the corresponding point. So I'm going to come around and I'm going to use those y coordinates as I go around. Okay, now for your graph, we'll talk about the table of values in a second, but for your graph, I really should have used a different graph with a different scale. Typically your trig functions has a graph that is set up already to deal with your pi, and I didn't do that, so we're just going to adjust this one. We're going to start at 0, we're going to go over 1, 2, 3, 4, and that's going to be our pi, and then 1, 2, 3, 4, that's going to be our 2 pi. And then going backwards, 1, 2, 3, 4, that's negative pi. 1, 2, 3, 4, that's negative 2 pi. And then on our y-axis, 1, 2, 3, 4, that's 1. 1, 2, 3, 4, that's negative 1. You'll see why I only need those particular values shortly. Okay, now you can see on my table of values here, I've only done the pi over 4s, because the multiples of pi over 4, because when I go to graph here, I split my pi into pi over 4, pi over 2, 3 pi over 4, pi. So I split my graph into chunks of pi. So graphing pi over 3, pi over 6 is going to be kind of a pain, so we're just not going to do it. They're still going to get graphed, we're just not specifically going to plot those points. Okay, so watch what happens here. Oops, thought I could zoom in, but I can't. So when I'm at 0 radians, my y coordinate is 0. When I'm at pi over 4, my y coordinate is square root 2 over 2. Now, I will say, I was going to show you on my calculator, but somebody took my calculator. I don't know who that could be. My square root 2 over 2, if I punch it into my calculator, that's about 0.7. Square root 3 over 2 is about 0.9-ish, right? And then, of course, 1/2 is 0.5. All right, pi over 2, my y coordinate is 1. 3 pi over 4, square root 2 over 2. Pi, my y coordinate is 0. I'm just going right around my circle here. So I'm right here now. 5 pi over 4. My y coordinate is negative square root 2 over 2. 3 pi over 2, my y coordinate is negative 1. 7 pi over 4, negative square root 2 over 2. And then 2 pi, I'm at 0. So these are the points I am going to plot. And here we go, let's do it. So start at 0, 0. Now, this right here is pi over 2. This is 3 pi over 2. So that means that in between, that's my pi over 4, my 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi over 4, 8 pi. So I'm just going to go up and then go down. So square root 2 over 2, which we said was 0.7, so that's 0.5, that's 0.75, so somewhere right in there. Pi over 2, I'm at 1. 3 pi over 2, I'm here again. Pi, I'm at 0. 5 pi over 4, I'm at negative 2 square root 2. 3 pi over 2, I'm at negative 1. Back to negative square root 2 over 2. Back to negative 1. I could continue, but for now, let's just trace this in. It's going to be smooth, curvy, no sharp points. And I'll just go ahead and say it goes like that. What would happen as I went around the circle again, it's going to come up and come down again. And it's going to continue as you saw in that exploration. Going backwards, watch what happens. Let's actually just plot the quadrantal angles. So at negative pi over 2, which would be here, my y-coordinate is negative 1. So at negative pi over 2, my y-coordinate is negative 1. At negative pi, so that just means I'm going clockwise instead of counterclockwise, my y-coordinate is 0. At negative 3 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, my y-coordinate is 1. And at negative 2 pi, whoop, same as at pi, at 2 pi rather, and at pi, it's 0. So it's that same shape. And again, we could keep going backwards around the circle. That's going to give me my graph. Okay, so what I have shown here is 2 complete cycles. 2 complete cycles. All right, let's talk about our key features. So here we go. X and Y intercepts or roots. Notice that that is happening at 0, at pi, at 2 pi, and so on. And then it's also happening at the negatives of all of those. So it's happening at multiples of pi. Your x-intercepts, boom, 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 boom. Your y-intercept is just 0, 0. Now, you're going to have maxes or mins at pi over 2, 3 pi over 2. The next one's going to happen at 5 pi over 2, and so on. And then also those negatives. So they're going to happen at the odd multiples of pi over 2. You're going to get 1, negative 1, 1, negative 1. And there's no absolute max or min, because that 1, negative 1 is going to occur. Okay, so it's going to happen there, and the y value is going to be plus or minus 1. Okay, so the actual relative max or mins are going to happen at 1 and negative 1. They're going to be 1 and negative 1. They're going to happen at pi over 2, 3 pi over 2, 5 pi over 2, and all those negatives. Okay. Continuity, it is continuous. My domain is going to be all real numbers because it's continuous. My range, notice I'm going between 1 and negative 1. So from negative 1 to 1. Now the increasing and decreasing can be a little bit difficult because of the periodic nature of the graph. I'm increasing right here from negative pi over 2 to pi over 2. And then I'm going to increase again from 3 pi over 2 to 5 pi over 2. For now, let's skip this part. You can see where it's increasing and where it's decreasing, but the notation for writing it out can be a little bit difficult. So let's just skip that part for right now. It's never constant. And then again for the positive, we're here, positive. We're going to be positive again here. Negative here, negative here. I don't want to worry about the notation for writing it right now, so we're just going to skip that part. And then let's talk about our symmetry. I'm not going to do this part. I'm skipping lots of parts. I'm sorry. But we're a little bit rushed here at the end of the year. For our symmetry, notice that if I hold a pin right here at the origin and twist the first and second quadrants into the first and fourth into the second and third, they're going to match up. So it does have rotational symmetry about the origin, which means that it is odd, which does mean that f of negative x is equal to negative f of x, just so we can have that filled in. And then our end behavior, we're going to skip that for now as well. It's going to go up and down. As x approaches infinity or negative infinity, y doesn't approach anything. It oscillates. Okay, let's talk about these key words down here, because these are important. We already talked about domain and range. I don't know why I put it a second time. The range affects the amplitude. So the range, see how I'm going from -1 to 1? There's this little invisible line right here at the x-axis. That's our midline. It's in the middle, halfway between the max and the min. Your amplitude is from that midline up or that midline down. So my amplitude in this case is 1, because from the midline up to the maximum is 1. From the midline down to the minimum is also 1. So my amplitude is 1. Okay. The period is the time it takes to complete one cycle. So from 0 to 1, back to 0, but I haven't completed the cycle. Otherwise I would need to do that same shape again. Down to 0, down to -1, back to 0. At this point, when I cycle around that circle again, that's when I'm going to get the same loop. So see here, I went from 0 to 1 to 0 to -1 to 0. One cycle. Then I did it again. It took from 0 to 2 pi to do that. So my period here is 2 pi. Okay, so I know I skipped a lot, not because you can't understand the concept, but because I don't want to go into the notation for writing it. It's also why my notation up here is just a little bit strange. The basic thing you need to know is this shape, and then we'll compare this to our cosine when we get our cosine done.